Hi students, in this video we're going to cover values of trigonometric functions with and without calculators. Our objectives are to define sine, cosine, and tangent using an angle theta, with an angle theta using the unit circle. We're going to learn the trig values of special angles, and we're going to use a calculator to find the values of the three trig functions. All right, so first, let's talk about sine, cosine, and tangent. All right, so first, sine is the ratio of the side opposite angle theta. It's a signed vertical distance. When we say signed, we mean either positive or negative. It's the distance from the horizontal axis to the unit circle, to the circumference of the unit circle. It's indicated by this purple line that we have. When we talk about cosine, we're talking about the ratio of the adjacent side, which is the side that's on the horizontal axis, and it's a signed distance from the origin, either positive or negative. Positive in quadrant 1 and 4, negative in quadrant 2 and 3. And then the tangent is the slope of the line segment that makes the terminal side of the angle. So in algebra, we know that slope is just rise over run, and that's all it is in trigonometry, except we just have different names for the rise, which is the sine value, and the run, which is the cosine value. So when we find tangent, we're just finding the slope of the line segment. So first is the trig values of the quadrantal angles. A quadrantal angle is an angle that falls on either the x or the y axis. They are multiples of 90 degrees or multiples of pi over 2. So we're talking pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and so forth. So we're going to write down those values and label them in degrees and in radians. These values are either 0 or 1. Remember, for a point on the unit circle, let me zoom out. For a point on the unit circle, cosine theta, which is the x value, comes first, and then we have the sine of that value. So for 0, 1, the x coordinate is 1 and the y coordinate is 0. So cosine is 1, sine is 0. This angle is either 0 degrees or 360 degrees, depending on where you're on the unit circle. And in radians, that's going to be just 0 and 0. At the top of the unit circle, we have 90 degrees. In radians, that's going to be pi divided by 2. The cosine value is 0 because we're on the y-axis. The sine value is 1. Oh, and the tangent here is undefined. So the tangent value is undefined. Over here, we're going to put tangent equals 0. The next angle that we have is 180 degrees. In radians, that's going to be pi. The x value, which is cosine, is -1. The sine value is 0. The tangent is also 0 degrees, so tangent pi equals 0. Actually, it's terrible notation by me. That should be tangent 0 equals 0 over there. And tangent pi over 2 is equal to undefined. And then the last quadrantal angle that we have is 270 degrees. So 270 in radians is 3 pi divided by 2. And that tangent is also undefined. So tangent 3 pi over 2 is, all right, we're going to do empty set. That also means undefined. And the coordinate is 0, -1. So now we can see that if we go around and just add pi over 2, we're starting here. We have 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. And if we go back, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and so forth. So these quadrantal angles, we're just adding pi over 2 or 90 degrees each time to get them. So next, before we move into our the trig functions for the special angles, we're going to talk about a reference angle. A reference angle is an angle, it's an acute angle that is the difference between an angle and the positive or negative horizontal axis. If an angle is in quadrant 2, you find the reference angle by subtracting that angle from 180. So all of these angles that we have they use 30 degrees as a reference angle. So here we have this value is clearly 30 degrees because it's labeled right here. So in quadrant 2, you have a 150 degree angle. The reference angle is this difference between the terminal side of the angle and the negative x-axis, and that's just going to still be 30 degrees. Now, the reason a reference angle is important is that all trig functions, all of the trig values for the angles from 0 to 90 degrees, the angles in quadrant 1, the other angles in quadrants 2, 3, and 4 have the same trig value as their reference angle, except the value may be multiplied by -1. So in the case of 150 degrees, because its reference angle is 30 degrees, it's going to have all of the same trig values as 30 degrees, except they may be multiplied by -1. So then when we look at 210 degrees, because it's a quadrant 3 reference angle, you're going to do that angle, which is 210. So 210 minus 180, that's going to give us 30 degrees. The quadrant 2 reference angle was 180 degrees minus 150 degrees, which gave us 30 degrees. And in quadrant 4, we have 330 degrees. So we're going to do 360 degrees minus 330 degrees, and that's still going to equal 30 degrees. So in all of these cases, our reference angle is the difference between the angle and the horizontal axis. And then you can take the absolute value if you want. So at the bottom, we have this small note that says always use the horizontal axis to find your reference angle. All right, so here's a quick check coming at you. All right, so you find the reference angle for each one of these angles. All right, so if you pause this and kept working, you should have gotten that your reference angle here is 60 degrees. For the angle that's 260, our reference angle is the difference between 260 and the angle 180. So that's going to be 80 degrees. For 340, our reference angle is right here. That's going to be 20 degrees. For a negative 165, you can kind of ignore the negative, and we're just doing 180 minus 165. That's going to be 15 degrees. And then for negative 510 degrees. So this one's different. So let's add 360 to this value. Let's zoom in, and we'll add 360. That's going to give us negative 150 degrees. So now negative 150 degrees is something that we can work with. And so if this amount is negative 150 degrees, that means that reference angle has to be 30 degrees. So reference angle of 30 degrees. All right, can I get back to the normal size? All right, so that's finding the reference angle in degrees. Now in radians, I'll see if you can come up with a trick for doing this. Here it is. So pause the video and see if you can come back for the answers. All right, so if you're rejoining me, 16 pi over 9. So now the reference angle is the difference between this angle and the angle here. So that's going to be 2 pi. So 2 pi minus 16 pi divided by 9. If we get this in radians, we're going to have, convert this to ninths. We're going to have 18 pi over 9 minus 16 pi over 9, which is going to equal, 2 pi over 9? So 2 pi over 9 radians as the reference angle. Most of the time, you can just drop the number in front of the pi and just make it pi over 9. But to be on the safe side, just do pi or 2 pi plus or minus that angle. So in this case, for the second one, we're going to have, because it's in quadrant 2, we're going to have pi minus 2 pi over 3, which is going to be just 1 pi over 3. For the angle for 7 pi over 6, since it's in quadrant 3, we're going to do 7 pi over 6 minus pi, which is the same as 6 pi over 6. And so we're going to get pi over 6 as our reference angle. 41 pi over 12, we're just going to subtract 2 pi first. So 41 pi divided by 12, take off 360 degrees. That's the same as subtracting 24 pi. So that's going to give us 17 pi over 12. So now we see that angle still in quadrant, the angle's in quadrant 3. So now we're going to do 17 pi over 12 minus pi, which is the same as 12 pi. I'm sorry. We're subtracting pi. Yeah, so 12 pi over 12. That's going to just be 5 pi over 12 as our reference angle. And then for this angle that is in quadrant 2, anytime the angle, we'll see that this is a special angle, and it's just going to turn out that pi over 3 is that reference angle. Now, again, for the special angles, you can just drop the number in the numerator, and that's your reference angle. So in this case, we just drop the -10, and that gives us pi over 3. The other way to do this, the way we've done the rest, is first add 2 pi. So that's going to give you -4 pi over 3. And then you would then add pi, and we get 3 pi over 3. So that's going to give us -pi over 3. But again, ignore the negative for reference angle, and we still get positive pi over 3. All right, so now the special trig angles are the angles that are multiples of 30, 45, and 60. Respectively, in radians, those angles are pi over 6, pi over 4, and pi over 3. So all of the angles that are multiples of pi over 6, they're going to have the same trig value, except the sign might be positive or negative. So first, let's go through and do all of the 30-degree angles. So we're going to have 30 degrees is right here. In radians, that's pi over 6. In quadrant 2, we have 150 degrees. In radians, that is 5 pi divided by 6. In quadrant 3, we have 210 degrees. That is 7 pi over 6. And in quadrant 4, we have 330 degrees, and that is 11 pi divided by 6. So we're going to color code this a bit, and we're going to we'll make all of these angles red. You see that spam risk is calling me. I don't know what they want. So, all right, so we're going to highlight all of our 30-degree angles in red. So we'll get this, and we'll get that angle. All right, so for 30 degrees, the cosine value is positive square root 3 divided by 2, and the sine value is 1/2. And so then, because in quadrant 2, remember, sine's a y value. Sine's the positive distance between the horizontal axis and the point on the unit circle. So sine is also going to be 1/2 450. Now the x distance is just the opposite of square root 3 over 2. So that's going to just be negative square root 3 over 2. For 210 degrees, we're going to have the x is negative and the y is negative. So we're going to get negative square root 3 over 2 for the cosine value and negative 1/2 for the y value. In quadrant 4, the x is positive and the y is negative. So we're going to get square root 3 over 2 and negative 1/2. And the tangent, we'll talk about tangent on these other slides, but tangent is just, again, is just the ratio of sine to cosine. So the tangent is really 1/2 divided by a square root 3 over 2, which is just 1 over the square root of 3, which if you rationalize the denominator is square root 3 over 3. And remember, tangent is the slope of the line. So the angles that's pi over 6 and 7 pi over 6, those tangent values are positive. For 5 pi over 6 and 11 pi over 6, the tangent is negative. You know what? Let's just go ahead and put it on here. So this slope is square root 3 over 3. And this slope is negative square root 3 over 3. That's the tangent value, the slope of that line segment. All right, so that takes care of our 30-degree angles. For the next angle that we have is 45 degrees. Take that back. Give me my 1/2 back. So 1/2. Next, we're going to have to choose a different color. Let's go with green. All right, so for 45 degrees. So 45 degrees is going to be, go back. So we have 45 degrees here. In radians, that's pi over 4. The angle in quadrant 3 that uses 45 as a reference angle is 135 degrees. That is 3 pi divided by 4. The reference angle, the angle that uses 45 as a reference angle in quadrant 3 is 225 degrees. And that's 5 pi over 4. And in quadrant 4, 7 pi over 4. So we get 7 pi over 4, and that is 315 degrees. So now we're going to just highlight all of these in green. Let's use a highlighter instead. Hopefully that goes quicker. It's not crazy either. All right, so all of the multiples of pi over 4 or 45 degrees are going to be on this green angle. So now for 45 degrees, the cosine, for all of the angles that are multiples of 45 degrees, the sine and cosine value they're the same value in absolute value. And that number is square root 2 divided by 2. So cosine is square root 2 over 2, and so is sine. So remember, in quadrant 2, the x is negative, which means that the cosine value is negative. So negative square root 2 over 2. The sine is still square root 2 over 2. In quadrant 3, both sine and cosine are negative. So we're going to have negative square root 2 over 2 and negative square root 2 over 2. And in quadrant 4, we're going to have the x is positive, so square root 2 over 2, and the y is negative, so negative square root 2 divided by 2. Now remember, tangent is sine divided by cosine. It's the ratio of sine to cosine, the rise over run. So the slope of this line segment is tangent pi over 4 is equal to 1. And for this other line segment that goes through quadrant 2 and 4, the tangent of pi over 4 is negative 1. And so the last special angle that we have is all of the angles that use 60 degrees as a reference angle. So we have 60 degrees in radians, that's pi over 3. In quadrant 2, that is 120 degrees. And that is going to be 2 pi over 3. In quadrant 3, that is 240 degrees. And that is 4 pi divided by 3. And in quadrant 4, that is 300 degrees, which is 5 pi divided by 3. So The 60-degree angle, it has it flips the 30-degree trig values. So like 30 has a cosine of square root 3 over 2. 60 is going to have these should be in, let's do these in blue so that's not confusing. I apologize. I just caught this. So pretend all this is in blue. So that's going to be square root 3 over 2 for the sine value. And the cosine is going to be 1/2. And so then in quadrant 2, sine is still positive. So that's going to be square root 3 over 2. The cosine is going to be negative 1/2. In quadrant 3, both sine and cosine are negative. So negative 1/2 and negative square root 3 over 2. And then in quadrant 4, cosine is positive. So that's going to be positive 1/2 and sine is negative. So negative square root 3 over 2. And again, tangent is the sine value divided by the cosine value. So square root 3 divided by 2 divided by 1/2 is just the square root of 3. So we're going to get the tangent of, we'll write it up here, I'm sorry. So the tangent of pi over 3 is equal to just positive square root 3. And on the other line, we're going to have the tangent of, we'll call it 2 pi over 3, for instance. So 2 pi over 3 is equal to negative square root 3. And then we're just going to highlight these in blue so we can see all of our 60-degree reference angles. So we get that one and we get that one. So these are the special angles. Now, again, if you know what happens in, take that back. So if we know what happens in quadrant 1, we know the rest of these values because they're just the same or multiplied by negative 1. All right, so a quick check coming at you. If I can get to the next slide. All right, so quick check 3, you find the sine, cosine, and tangent of each angle. All right, so 240 degrees, that is an angle who has a reference value of 60 degrees. So we know the sine, why am I use? I don't want to use that. Let's we'll go in blue then. So the sine of 240 degrees, that is the same as the sine of 60, but multiplied by negative 1. So it's going to be negative square root 3 over 2. The cosine of 240, since it's in quadrant 3, is also negative. That's going to be negative 1/2. And the tangent is just sine divided by cosine. So negative square root 3 over 2 divided by negative 1/2 is positive square root 3. For 210, 30 degrees, so we'll write the reference angle, 30-degree reference angle, and the sine of 210 degrees is equal to negative 1/2 because it's in quadrant 3. The cosine of 210 is also negative. It's negative square root 3 over 2. And the tangent of 210 degrees is going to be negative 1 over, just positive 1 over the square root of 3, which simplifies to be square root 3 over 3. For 5 pi over 6, pi over 6 is the reference angle. Pi over 6 is we're going to abbreviate reference angle. And let's see, the sine of 5 pi over 6 is 1/2. The cosine of 5 pi over 6 is negative square root 3 over 2. And that's going to make the tangent of 5 pi over 6 equal to negative square root 3 divided by 3. Now you can see 210 and 5 pi over 6, they have the same trig values because they have the same reference angle. Again, up to multiply by negative 1. And so 7 pi over 4, that's in quadrant 4, reference angle pi over 4 is the reference angle. So the sine of 7 pi over 4 is equal to negative square root 2 divided by 2. The cosine is positive because it's in quadrant 4. So cosine 7 pi over 4 is positive square root 2 over 2. And the tangent of 7 pi over 4 is just negative 1 because it's sine divided by cosine. All right. So now finding trig values with the calculator is exactly what you think. You will just need a calculator to do this. Make sure your calculator is in the appropriate mode. Radians if you don't see a degree symbol, degrees if you do see a degree symbol. So for the first one, first put your calculator into radian mode. We'll talk about how to do that in class. So you press, you press mode, and then you just go down to where you should see radian or degree if you're on a TI, and select radian for this one. Go back to the main screen. And so the sine of 7 pi over 6, you just put it into the calculator. So the sine of 7 pi divided by 36, divided by 36 is, I get 0.574 equals 0.574. The cosine of 49 pi divided by 30, we just again put in the calculator. I get 0.407. 0.407. You know what? Let's do the last one because it's also in radians. We don't have a degree symbol, so that's how we know it's in radians. The cosine of 1.4 is, I get 0.17 rounded to 3 decimal places, so 0.17. And so now for tangent, we want to the tangent of 215, we want to go back and put the calculator in degree mode. So do that and go back and put in 215, tangent to a negative 215. So tangent negative 215 is going to be negative 7. Negative 0.7, I'm sorry, is negative 0.700. All right. So that's doing our trig functions with a calculator. The last thing that we're going to do is, if you have a trig value and you have to find the other two, here's how we do it. So we know the sine of theta is negative 7 divided by 25, and that theta is in quadrant 4. So the first thing we're going to do is draw our angle theta. So theta is negative. The sine is negative, so this is our theta. So theta is this angle that we drew, and we get a reference angle though. So the reference angle is whatever 2 pi minus theta is. But when we draw an angle, it creates a right triangle. So since sine is negative, that means that the y value is 7. And remember, the bottom number is the hypotenuse. So that is 25. Now, really, that's a negative 7. So we'll put in a negative 7. And we can just create a right angle here. So now we want to find the sine and cosine value. So to find cosine, we need to find this x distance here. So all we have to do is the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So what we have is perhaps b and c. So we're going to say a squared plus negative 7 squared equals 25 squared. So it's going to be a squared plus 49 equals 625. We're going to get a squared equals 576, and you take the square root of both sides. So a equals plus and minus 24, because the square root of 576 is 24. Now we would use the negative if we were in quadrant 3, because the cosine value is going to be negative. But since cosine is positive in quadrant 4, we're going to use positive 24. So we know this length is 24. And so now we're going back to our geometry days, where the cosine of theta is going to be So now if this angle is theta, the reference angle that we can get is also theta right here. I'm sorry, is right here. So the cosine is going to be 24 over 25. So it's going to be the x distance over 25. And then the tangent is just going to be the sine divided by the cosine. So that's going to be -7 over 25 divided by 24 over 25, which of course is -7 over 24. Now, if we go back to our geometry days, we know that's going to be just opposite over adjacent. That's how we get our trig value. So that's how we do this given the actual, like a sine or a cosine value, and we have to find the other two values. The next thing is, what if we have a decimal instead of like a fraction? It's the same process. Now, this time we're given that theta is between pi and 3 pi over 2, which is telling you that theta is in quadrant 3. So we get our angle. So in this case, theta is here. So theta is that angle. And so what we can do again is just draw a right triangle to the horizontal axis. So if we're going to get a reference angle again of whatever theta minus pi is, but we know that cosine is -0.47. So we're going to make this value -0.47. And remember, cosine can just be understood to be divided by 1 if we don't have a denominator. So the hypotenuse is 1. And so what we need to find is this value is going to be sine theta. So now sine should be negative because the angle is in quadrant 3. So let's go. So we're going to get, again, using the Pythagorean theorem, we'll say a squared plus -0.47 squared is equal to 1 squared. I have no idea what 0.47 squared is. So 0.47 squared is, so we're going to have a squared plus 0.2209 is equal to 1 squared is still 1. So a squared is going to equal, what's that? 7791. 0.7791, 1 minus 0.2209. Yep. And so a is going to equal plus and minus the square root of 0.7791, which is, let's round to 4 decimal places. So 0.8827 plus or minus. But since sine is negative, we're going to have sine theta is -0.8827. And then tangent theta is going to be sine theta divided by cosine. So it's going to be -0.8827 divided by -0.47, which is probably close to like 0.4 or a half. So 0.8827 divided by 0.47 is, I was way off on this, and I teach math for a living. So that's 1.88, 1.88. I did it the other way. I did 0.47 divided by 0.88. So 1.88 is the tangent value. All right. And the very last example is kind of the same question, but we are given a point on the terminal side is -2, -11. So we're doing something different. Let's make it +2. Let's make it -2, +11 instead. So -2, +11. So -2, say +11 is up here. And again, we need to find the trig value. So in this case, we are given, we're kind of given the 2 legs of a right triangle. That side is 2, was technically -2, and that side is 11. So we already know that the tangent of theta is going to be the ratio of the opposite to the adjacent. We'll see that in a moment. So theta is going to be I'm sorry, let's go. So we're going to have 11 squared plus negative 2 squared is equal to c squared. That's 121 plus 4 equals c squared. So 125 equals c squared. So I don't know, square root of 125 is 11 point something. Is 11.2. So we'll say 11.18 is equal to c. We'll round it to 2 decimal places. So plus and minus 11.18. So the hypotenuse is 11.18. So now the sine is the distance. The point is above the x-axis. So in this, but going back to our trig days, since we're not on the unit circle anymore, we can also say this is our theta. So we're going to get opposite over hypotenuse. So the sine of theta is 11 divided by 11.18, which is 0.98. So 0.98. The cosine of theta is negative 2 divided by 11.18, which equals negative 2 divided by 11.18 is negative 0.18. And the tangent is just going to be sine over cosine. So 0.98 divided by negative 0.18 is close to, is over 5, I know. So it's negative 5.44. So negative 5.44 is the tangent. All right, so that concludes this video on the trig values using a calculator and without a calculator. For reference, here is a unit circle completely filled out that's color-coded by reference angle. And here's a unit circle that is color-coded by accumulating radians. All right, so you guys